Now we are going to talk about cranking batteries and deep cycle batteries. What is the main difference between those group of batteries? The cranking batteries are batteries with the ability to release the electron quickly in a short period of time. And at the same time, the cranking batteries have the ability to be charged quickly again. In other words, when you use the cranking battery, you practically discharge the battery at the minimum time. But when the engine starts, the alternator of the engine charges the battery immediately. Because those batteries, the cranking batteries, have the ability to be discharged quickly and recharged quickly. Why? Because internally, the metals, the plates, the metal used in the batteries is lead. And is basically plates of lead connected in series, like I explained before. And I am going to explain later exactly how is the configuration inside. Okay, the plates inside of the cranking batteries are thinner plates. Those plates have the ability to storage and release the electrons easily because it's a little area. Yeah, this is the ability of the cranking batteries. Okay, this type of batteries have a thinner and closer plates internally, providing more surface area to give the higher one-time discharge power during the cranking process. The cranking batteries have many thin lead plates that provide the ability to be discharged at that time. Okay, be careful when you discharge cranking batteries. Never discharge a cranking battery more than 50% of the capacity of the battery. And of course, never discharge a cranking battery completely. If you discharge a cranking battery completely more than 2 times, you destroy the battery. The cranking batteries never be discharged more than 50%. This is an ABYC recommendation. This is one of the questions on the ABYC test related with batteries is how much should be discharged the battery? Maximum 50%. This is the maximum capacity. The cranking batteries, they don't tolerate being discharged deeply. This is an important recommendation. The majority of the battery cranking batteries will only tolerate being completely discharged a few times. I recommend never discharge a cranking battery completely. 100% sure you damage the battery. More than 2 times the battery is out. Be careful, the marine batteries are expensive batteries, depending on the quality and the capacity in amps per hour. Right now we are going to talk about that. Deep cycle batteries. Deep cycle batteries, what is the difference between the cranking batteries and the deep cycle? The deep cycle batteries have a thicker plates. The plates are thicker. Why? Because the deep cycle batteries storage more electrons and release the electrons slowly during the day. Oh yeah. Those batteries are used for the house bank, or for RVs, for boats, for sailboats. You need deep cycle battery because you want electrons during the day and during the night and during the day and during the night again. In other words, you need release the electron of the battery slowly. You need to storage a big amount of energy and release the energy slowly. What happens if you use cranking batteries for the house bank in a sailboat? Probably the bank is discharged quickly. That's good for you in a sailboat. That the sailboat depends basically of the solar panels. That's not good. For that reason, the house bank should be configured with deep cycle batteries. The cranking batteries, like your name said, are designed to configure cranking, starting groups for cranking, for crank engines or generators. Yeah. The deep cycle batteries, they cannot dispense the charge as quickly as the cranking batteries, but can also be used for cranking purposes, normally in small engines. The deep cycle batteries can be used for cranking purposes in small gasoline engines. In a big diesel engines, the cranking batteries, the starting battery should be dedicated cranking batteries with high capacity in amps per hour. We are going to talk later about that. Of course, now we are going to talk about the battery charger dedicated for deep cycle batteries. The plates on the deep cycle batteries are thicker plates, and the battery, of course, the weight of the battery, the deep cycle batteries are too heavy in comparison with the cranking batteries, because the cranking batteries, the plates are thinner, and the deep cycle batteries, the plates are thicker, are big plates. The deep cycle batteries are also commonly used in golf cars, in solar power systems, because they store a big amount of energy. One important thing, the majority of the batteries are on the market are available in 6 volts, 8 volts, and 12 volts. But you can configure the batteries in series or parallel in order to produce 12 volts or 24 volts or 36 volts or 48 volts. The batteries in the market, depending on the voltage, they have a more, not depending on the voltage, depending on the construction, they have more or less capacity to storage electrons. But in general terms, the batteries with lower output voltage, for example, the 6 volts batteries commonly used in golf cars, are the batteries with bigger capacity to storage electrons in amps per hour. For that reason, those golf cars batteries are commonly used in sailboats in order to create a big group of batteries for house. This is very common, and of course are used in golf cars in order to provide a big amount of energy during the day, because you use the golf car for a long period of time and you need that the batteries release the electrons slowly, but you need that the batteries storage a big amount of electricity. For that reason, deep cycle batteries, low voltage 6 volts and high current 800 amps or more per hour are excellent for those situations. We are going to talk later about those capacities. Crank or deep cycle. What is better? What is more recommended? A cranking battery is designed to provide a very large amount of current, amps per hour, for a short period of time. Once the engine starts, the alternator provides all the power that the engine needs. So a cranking battery may go through its entire life without ever being drained more than 20% of its total capacity. A deep cycle battery is designed to provide a steady amount of current over a long period of time. A deep cycle battery is also designed to be deeply discharged over and over again. However, I don't recommend discharge the battery completely. Never discharge the battery more than 50%. That's my recommendation. Internally in the batteries, you have the plates, and the plates are connected in series. Each cell have one positive plate and one negative plate. The next cell have other positive and other negative. The next cell, remember, for a 12 volts battery, you have 6 cells. The negative terminal of the first cell is connected with the positive of the second one, and the positive of the second one is connected with the negative of the third one. And finally, you have one negative free and one positive free, and this is the output of the battery, the positive and the negative. In other words, this is my negative terminal. In the first cell, the positive of this is connected with the negative of the second one, and the negative of the second one is connected with the positive of the third one, and finally this is the output of the battery, negative and positive. In this particular case, if I connect the voltmeter, the reading should be 12.4, 12.5, because in each cell you have 2.07 or 2.1 volts maximum when the battery is fully charged. When each cell is full charge, the maximum volts is 2.1. For that reason, when a battery is full charged, normally the voltage should be 12.6, 12.7 volts. This is the indication that the battery is fully charged. 12.0, it's not full charged. It's probably 80% charged. Yeah. 11 point, that's not good. Right now we are going to talk about that amount of charge in each cell. Yeah, we talk about the electrolyte. The electrolyte in a lead acid battery is a hazard material. It's a composition of water, fresh water, and acid. What type of acid? Sulfuric acid. Fresh water, no salt water. Fresh water. Salt water is not good because salt water have too much minerals, too much metals. Yeah. Fresh water is better. Fresh water doesn't have those minerals. Fresh water is not a good conductor, but the acid is a good conductor. How much is the composition of water and acid? Is around 65 and 35. 65 of water, 35 of acid. The battery electrolyte is a mixture of water. The density of the water is 1,000 grams per cubic centimeter, and sulfuric acid, and the density is 1,800 grams per cubic centimeter. Since the flow of electricity into and out of a battery results in either generation of sulfuric acid or loss of sulfuric acid. We are going to talk later about that. The level of the charge in a battery is directly related with the density of the electrolyte. Okay, pay attention to this. The electrolyte is composed by water and acid. What is heavy? The water or the acid? The acid. The density of the acid is 1,800 grams per cubic centimeter, and the density of the water is 1,000. Okay. The acid is heavy and the water is light. In other words, when the electrolyte is calm, the acid is in the bottom and the water on top. Yeah? Okay. Don't forget that. Alright. Look at this picture. This picture is very important. What happens when one cell is completely discharged? What happens with the electrolyte inside of the cell? When the cell is completely discharged, the electrolyte is maximum amount of water and practically no acid. What happens when the cell is full charge? When the cell is full charge, the electrolyte is practically pure acid and a little amount of water. What happened with the acid during the charge and discharge? When the battery is completely discharged, maximum level of water and a little amount of acid, the acid is impregnated on the plates. Once again, when you connect the battery charger and the battery is charged again, the acid goes into the water and is mixed with the water. When the battery is discharged, the acid is impregnated on the plates of the battery. That's clear? When the battery is full charged, the electrolyte is maximum level of acid. And when the battery is full discharged, is practically pure water and zero acid. Okay, for that reason, if I check with the hydrometer the density of the fluid, if the fluid is too heavy, it's because it's more acid or more water? More acid. When I have more acid, is when the battery is full charged. When I check the density of the fluid, if the needle of the hydrometer goes to the maximum, it's because the battery is full charged. If the needle of the hydrometer goes to 0, it's because the density is low, it's because the amount of water is maximum, and it's because the battery is discharged. Yeah, this is one technique to check the level of charge in a battery is with the hydrometer. Other technique is, right now I am going to explain, is with the load tester. I prefer the load tester because with the hydrometer you splice acid, you damage your clouds, and the acid is corrosive. I don't like. I prefer use the load tester. It's clean, it's safe, and with the hydrometer you spill acid on the engine room. I don't like that. I don't recommend. But it's a technique used in some shops, but inside of the engine room, I don't recommend. That's okay. And also, the odor of the engine room is acid. It's not good. Remember, my friends, I recommend that you be familiarized with the odors inside of the engine room. This is critical, this is important. If you are the engineer in a boat, if you are the captain, if you are the owner, you need to be familiarized with your boat, with the engine room. And you need to be familiarized with the odors. The odor of the gasoline, the odor of the diesel, the odor of the electrolyte of batteries, the odor of the coolant, the odor of the hydraulic oil, the odor of the hydraulic oil, motor oil, transmission oil. All of those fluids have a different odor, and you need to be familiarized. What is the first step when you open the engine room in a boat? Smell. I have a leak of hydraulic fluid. I have a leak of acid. One battery is broken. I have a leak of coolant. For that reason I have high temperature in the starboard engine. You need to be familiarized with the odors. This is important. This is very, very critical if you are the engineer or if you are the captain, because you need to solve the problems in fraction of seconds. Okay? Be familiarized with the odors. Okay? If the battery is fully charged, the electrolyte is maximum acid. If the battery is fully charged, the electrolyte is basically pure water. Okay, what happened with the cells of the battery when the battery are fully charged or full discharged? Okay, each lead acid cell fluctuates in voltage from around 2.1 volts, in between 1.75 and 2.12. What is the meaning of that? When the voltage of one cell is 2.12, the cell is 100% charged. And look, this is the voltage of one cell, 2.12 per cell, or 12.7 for the battery. Or if the battery is 90% charged, the voltage per each cell is around 2.08, and the total voltage of the battery 12.5. What about 12.4? 12.4, the battery is charged only 80%. What happened with the 12 volts? 12 volts, the battery is charged 50%. It's in the limit. For that reason, when the customers call to me and say, I have a problem in my boat, the starboard engine start easily and the port engine only click and not start. Mr. Lopez, but the batteries are perfect. Oh yeah, they are perfect. Why? Yeah, the voltage is 12 volts. Oh yeah, and you hear only click. The problem are the batteries. The batteries are in the limit, 50%. No, it's 12. 12 is 50%. 12 is in the limit. This is the minimum accepted. Less than 12, nothing. Alright? What is a good voltage? Over 12.3. 12.3 and up is good. But less than 12.3 is not accepted. For that reason, you need to install voltmeters and ammeters inside of the engine room in order to verify the condition of each group of batteries. If you are the engineer, you need to be familiar with those levels of charge and be familiar with the connection of the battery chargers in order to verify if the battery chargers are working properly. Okay, the electrolyte is a solution of 65% of water, 35% of sulfuric acid, like I explained before. The specific gravity or weight of the solution increase at the battery charge and decrease at the battery discharge, like I explained before. The density decrease when the battery is completely discharged, and the density, the weight of the liquid, increase when the battery is fully charged. This is a quiz question, ABYC question, final test question. This is a question that you found it in all the ABYC tests for diesel, for gasoline, for any type of ABYC certification. You found that question. The density of the fluid decrease when the battery is completely discharged, and the density of the electrolyte increase when the battery is fully charged. This is another example. This is like I explained before. As the battery discharges, the sulfur moves away from the solution and toward the plates. The opposite is true. As the battery is charged, the sulfur returns into the solution. That's the composition, the specific gravity, and this is the hydrometer. You are familiarized. I forgot to bring that hydrometer today for the presentation. Sorry, I apologize. But this is the equipment. You are familiarized with that. It's a hand pump. You suction the fluid and you release the fluid. I don't like because you splash acid and you damage your clothes and you ruin the paint on the engine room. Look at this. This is the needle. When the needle is on top in the green or blue area, it's because the density is high density, is because the battery is fully charged. When the needle goes down, it's because the density is low and the needle is pointed in the red area, the battery is full discharge. This is the hydrometer, and of course, when the needle is on top, the density is around 1.3 and 1.27. When the density is in between 1.27 and 1.3, is because the battery is fully charged. When the density is below 1.2, the charge is not good. If the density is below 1.21, the battery is completely discharged. This is exactly the same that I explained before. 1.27 is 100% charge, 1.23 75% charge, 1.19 50% charge, and below. Okay, there are gel batteries and AGM batteries. What is the difference between gel and AGM? The electrolyte is different? No. The electrolyte is water and acid, but in these batteries, in the gel batteries, is water plus acid plus a gel in order to avoid that the liquid spill. And in the AGM is water, acid, and a powder of silica. The powder of silica absorbs the electrolyte, and you can put the battery in different positions and you never spill liquid. In other words, all of those batteries, lead, AGM, and gel, they are lead acid batteries. But the gel use another component, a gel, and the AGM use a powder of silica to absorb the liquid. In other words, the gel batteries and the AGM batteries are excellent for sailboats because you can put the batteries in different positions and you never spill the electrolyte on the beach. Okay, but internally the electrolyte is basically the same. Lithium-ion batteries, those are excellent because lithium is one of the metals with the best capacity to storage electrons. The problem with lithium is the price of the lithium is too expensive. The lithium-ion batteries have a long life. The same like the cadmium. Okay, right now we are going to talk about 3 important concepts when you select one type of batteries or other type of batteries. In general terms, when you check the label of any type of battery, you found that one information is about the amps per hour. Other information that you found on the label of the batteries is about the RC, reserve capacity. And other information is related with the CCA, called cranking amps. Those three numbers are important. In my opinion, the most important are the amps per hour and the CCA, the called cranking amps. However, not all the batteries provide the amps per hour information. The majority of the batteries only provide the RC, reserve capacity, and CCA. But you can convert with a simple formula the RC, reserve capacity, into amps per hour. Amps per hour is the most important because you need to know how many amps per hour the battery delivers in each hour. And also, it is for a cranking battery for a big diesel engine, you need to know how much is the capacity of the battery at 0 degrees Fahrenheit. This is the cold cranking amp. Right now we are going to talk about that. Okay, what is the meaning of amps per hour? A battery with a capacity of 1 amp per hour should be able to continue supply a current of 1 amp to a load for exactly 1 hour. This is the basic explanation about amps per hour. For example, an average marine battery have the capacity of 7 amps per hour. This is the general capacity of the smaller Series 27 marine batteries. They supply 7 amps per hour. What is the meaning of that? 7 amps per hour specified at a current of 3.5 amps. Okay, this means that the amount of time that this battery could continually supply a current of 3.5 amps to a load would be 20 hours. In other words, 70 amps per hour divided by 3.5 amps is 20 hours. What is the meaning of that? If I have a battery with the capacity in amps per hour of 70, if I connect one blower and the blower suction 3.5 amps, this is the capacity of the blower, how many hours can I operate the blower on that battery? The capacity is 70 amps per hour. I suction 3.5. Oh, 70 divided by 3.5 is 20. Oh, I can use the battery 20 hours. To discharge the battery completely. But what is the recommendation? Never discharge the battery more than 50%. Okay, in that case, the recommendation is connect the blower no more than 10 hours. Because in 10 hours, the battery is discharged 50%. That's enough. Be careful with that. Never discharge the batteries more than 50%. Okay, this is the definition of amps per hour. This is an important definition. We are going to use the capacity of the battery in amps per hour all the time in order to calculate the bank for a group of solar panels. I'm going to explain later, and I am going to use that information, amps per hour, in order to calculate the battery bank for an inverter. I want to install an inverter in my boat. I want to calculate the capacity of the battery bank. That capacity is in amps per hour. When I say capacity, I am talking about amps per hour. That's okay? It's the capacity to storage amps in 1 hour. All right? Okay. The other concept is RC, reserve capacity. What is the meaning of RC? Reserve capacity is a complicated definition. I'm going to read the definition. You don't need to memorize that definition because I'm going to explain the procedure to convert the reserve capacity in amps per hour. The reserve capacity is not important. Forget that. We are going to use other important concept. It's amps per hour. That's okay? What is the meaning of reserve capacity? It's the number of minutes a fully charged battery at 80 degrees Fahrenheit is discharged at 25 amps before the voltage below 10.5 volts. That's too complicated. And we don't need to use that concept. To convert reserve capacity into amps per hour, you need to multiply the reserve capacity times 0.41 and you convert reserve capacity into amps per hour. That's very simple. What is the secret? You have the number, the reserve capacity, and you multiply times 0.4167 and you convert in amps per hour. Remember, reserve capacity is not the same like amps per hour. Amps per hour is the concept that we are going to use in the future to calculate the capacity of the battery bank. The majority of the batteries in the label, they show information about RC, reserve capacity. But you can convert that information if you multiply that number times 0.4167. You multiply the reserve capacity times 0.41 and you have the amps per hour. This is an important information, and this is the information that we are going to use in the future to calculate the capacity of the battery bank. Other information is about the state of the charge. Some boats they have on the pilot hand information about the state of charge of each battery bank. It's basically the same. What is the meaning of that? The state of charge describes how full a battery is. The exact voltage of the battery charge depends on the temperature of the battery. That's a function of the temperature. The depth of the charge, the DOD, is a measure of how deeply a battery is discharged. When the battery is 100% full, is full charge, the DOD is 0. When the battery is 100% empty, the charge, the DOD is 100. But the following term, the CCA, is a very, very, very critical information, especially when you select batteries for cranking purposes, for engines. It's the called cranking amps, the CCA. Be careful, the CCA is not amps per hour. The CCA is not reserve capacity. This is other concept, completely different, and is related with this. What is the meaning of CCA? CCA is critical for good cranking ability. This is basically a concept used in cranking batteries. It's the number of amps that a battery can support during 30 seconds at a temperature of 0 degrees Fahrenheit until the battery drops to an unusable level. What is an unusable level? Less than 10.5 volts. Below 10.5 volts, the battery is done. Okay, we are going to repeat the definition according with that. CCA is the number of amps that a battery can support during 30 seconds at 0 degrees Fahrenheit before the voltage decrease below 10.5 volts. Yeah, this is the meaning of CCA. A 12 volts battery with a rating of 600 CCA means that the battery will provide 600 amps for 30 seconds at 0 degrees before the voltage goes down below 7.2. 7.2 is too low. The recommendation is 10.5. Below 10.5, that's not good. This is the magic number. In some ABYC questions are related with that number. It's 10.5. Don't forget that number. Okay. Now we are going to talk about the battery, the load tester or battery tester. You remember that a couple of minutes ago I mentioned the hydrometer in order to verify the density of the liquid, the density of the electrolyte. Okay, this is a good tool to verify if the density is high density. If the needle goes up, it's because the battery is fully charged. If the density is low, it's basically pure water, the plastic needle goes down, and this is an indication that the battery is completely discharged. Alright, this is a good tool. But in my opinion, the best tool to check the battery condition is the load tester. Some people say, Mr. Lopez, I use always my multimeter, my voltmeter, in order to verify the condition of my battery. 12 volts, my battery is perfect. Now, papi, the voltmeter is not a good tool to check the condition of the battery. I have millions of examples. I receive phone calls every day. The customer says, Mr. Lopez, I don't know what happened with my engine. My engine when I try to start the engine, I only hear a click, but it's doing nothing. The battery is perfect. The cables are new ones. The switch selector is perfect. What happened? My friends, my battery is perfect. I have 12.5. In some cases, you have 12.5. But when you connect the load tester goes to 0. The battery is damaged. This is possible? Yes. The voltage, the indication of voltage with the voltmeter is nothing about the condition of the battery. This is the voltage in that moment. That's the potential difference between the positive terminal and the negative terminal. But the amount of amps storage is nothing. That voltage goes to 0 when you put a little load. Immediately it discharges the battery. For that reason, never try to check the battery. Okay, you can check with the voltmeter. Okay, I have 12.5. Probably it's good. I check with the load tester. Yeah, the voltmeter is an indication about the voltage of the battery. But the load tester is the tool recommended. This is the load tester. Check out the load tester. The load tester is basically here internally have a resistor, and here you have a needle. The needle in the red area indicates that the battery is completely damaged. When you apply a load here for 20 seconds, the needle stays in the red area or in the yellow area or in the green area. If when you apply the load, the needle is located in the red area, the battery is completely damaged. If when you apply the load, the needle stays in the yellow area, it's because the battery needs a little charge. If when you apply the load, the needle stays on the green area, it's because the battery is in good condition. Simple. This is excellent. This is the load tester. You need to apply a load for 10 seconds and verify where is located the needle. In the red area, damage. In the yellow area, you need charge the battery. The battery is not damaged. The battery needs charge. Oh, it's in the green area all the time. That's perfect. Simple. How you apply the load? Because they have resistors simulating load. This is the load tester. This is the less expensive equipment. This is hardware free. It's not expensive. You connect the positive terminal to the positive of the battery, the negative to the negative terminal. You apply the load and you verify the condition of the battery. It's too simple. This is the procedure to use the load tester, and this is a good tool. This is good, but it's not perfect. There are other load testers, electronic. This one, digital, electronic. This is excellent. This is excellent. You connect to the positive and the negative of the battery, and this equipment, the new ones like this, they have connections with internet, and you can print it, and you can send the email to the customer with the result of the load tester on the batteries. Okay. What is the advantage of this one with respect to the previous one? This one is excellent because immediately you connect the battery here. This equipment asks to you if the battery is connected to the engine or if the battery is isolated. This equipment asks to you about the capacity of the battery, the CCA, the core cranking amps. you introduce the amount of CCA on the label of the battery, and when you apply the load, this equipment sends the load appropriated for the battery according with the CCA, and you don't damage the battery. With this equipment, you send the load equally for any type of battery. Doesn't matter if the CCA is high or low, or doesn't matter if it's lead acid or gel. No, this equipment is excellent. This one asks about the type of battery, lead, gel, or AGN, and asks about the CCA, and asks about if the battery is isolated from the engine or connected to the engine. And after that, when you apply enter, this equipment apply the load exactly recommended according with this type of battery. And immediately the result is the battery is in good condition, the battery need more charge, or the battery is damaged. This is an excellent equipment. This is an electronic load tester. Of course, it's more expensive, but I recommend this one. If you have the chance, try to buy an electronic called load tester.